This is for class 12. Class 12. So based on concept. Here, this is the question I have taken from the textbook. That is, here you see the diagram. I have taken this from your textbook. This is Y, this is Z, and here this is X, and current is flowing in anti-clockwise direction. See, current is flowing in anti-clockwise direction, and here this is your magnetic field E. This is one case, and in another case here you see here. This is the loop where the current is flowing, and this is Y. Here again this is X, and here this is Z. Here you see the current is flowing in anti-clockwise direction. Anti-clockwise, this is the I current which is flowing in the anti-clockwise direction. And again, one more case, that is here. You will see this is your Y and this is your X. Then here you see the current is flowing in clockwise direction. Here you see the current is flowing in clockwise direction. This is your Z and this is your magnetic field P. Now here again one more case I am taking, that is here you see this is the loop. Here this is the loop, current flowing here. This is X, this is Y, and this is Z. It is flowing in anti-clockwise direction. It is flowing in anti-clockwise direction, and magnetic field is in Z. So here in all these cases the magnetic field is in Z direction. You have to find the torque and the force. So in every case your net force is 0 because it is in a uniform magnetic field. In every case it is your net force is 0 because it is in a uniform magnetic field. Now first case here, here you see torque. We have to find a torque. Torque that is equal to M cross B. M cross B. So again we know that magnetic moment that is equal to I A. This is the magnetic moment. So here the current is flowing in anti-clockwise direction. So your magnetic moment, it is flowing in anti-clockwise direction. So your magnetic moment will be M I cap. See, and it is in anti-clockwise direction. So your magnetic moment will be in this direction, and this is the magnetic field is in Z direction. That is B K cap. Now when you multiply it, torque that is equal to M B I cap into J cap. This will be minus I cap into this will be minus J cap. I cap, this will be minus J cap because I J K. So I to J it will be minus I to K. Sorry, I to K. So the torque this will be minus MB J cap. So here you see that your torque will be in the negative direction of the wire. Your torque will be in the negative direction of the wire. In the negative direction of wire. Negative direction of wire. So here you see the current is flowing in anti-clockwise direction. So your magnetic moment is along I cap, and the field it is already given to you. it is in k cap. So the torque here will be along the negative direction of the y-axis. Here again you see the same case, current is flowing in anti-clockwise direction. So your M will be M I cap, and your field, it is you know that your magnetic field is that is B J cap. So your torque will be minus MB J cap. So it will be also in the negative direction of the y-axis, negative direction of the y-axis. Now in this case you see that the current is flowing in the clockwise direction. Current is flowing in the clockwise direction. So this is in a YZ plane. Current is flowing clockwise direction. So this is in the YZ plane. Here you see it is in the YZ plane. It is in the YZ plane. This is in the YZ plane. So since this is in the YZ plane, here this is in the YZ plane. It is in the YZ plane. So here your magnetic moment, that is equal to M. Here you see clockwise. So it is minus J cap, and your magnetic field is in that is B J cap. So your torque here will be K cap. So your torque will be here. So J and then K. So JK, it will be I. So your torque will be minus M I cap. This will be minus M I cap. Your torque, because here see it is in clockwise direction, it is in YZ plane. So M will be minus J cap, and magnetic field it is given to you. So here your torque will be in the negative direction of the y-axis. It is in the negative direction of y-axis. X-axis, negative direction of x-axis. So here again, in this case, it is in the YZ plane, and the current is flowing in the clockwise direction. So in the clockwise direction. So here you find that it is clockwise direction. The magnetic field and the direction of this M, it is in the Z, along the Z axis. The magnetic field and this Z, it is in clockwise direction. So here it is in clockwise direction. So here your M, this is your I. So M will be, that is M minus K cap, and your magnetic field will be B K cap. So torque here will be K cap cross K cap, it will be 0. So here the torque will be 0. Here this torque will be 0. So here you see that this is a concept, based on concept. What will be, this is the loop, and here it is flowing in anti-clockwise direction. So here the torque will be in Y, negative direction of Y, and in this case it will be also in negative direction of Y, but in this case it will be in the negative direction of X, and in this case the torque will be 0. Now similarly, let us take a second type of concept, please. Here, let us consider a ring. It's a ring, and it is in a uniform magnetic field. And this is a rod, and it is rotating with angular velocity omega. It is rotating with angular velocity omega. This is a ring, metallic ring, and it is in a uniform magnetic field. So this rod is of radius r. It is rotating in anti-clockwise direction with angular velocity omega. So what will happen here, as it rotates in anti-clockwise direction, from Lorentz force, that is Q V cross B, because the velocity, cross is magnetic field, because the velocity and the magnetic field, they are at right angles, so your F will be equal to Q V B. This F will be Q V B. And the free electrons in this rod, free radius Br, and the free electrons in this rod will move outward. The free electrons in the rod will move outward, will move outward. The free electrons in the rod will move outward, and it will get distributed in this ring, and it will get distributed. It will get distributed in the ring. It will get distributed in the ring. Now the free electrons in the rod will move outward, and it will get distributed in the ring. Now what happened, that is an induced EMF is set up at this end, and induced EMF is set up at this end. Here an induced EMF is set up, and this induced EMF, that is equal to BVDR, and if you integrate it from 0 to R, your induced EMF, so 0 to R, V is equal to R omega, so R omega dr. So here this will be equal to B omega R square by 2. This will be your induced EMF. This will be your induced EMF. So here you see that this is a ring, and it is in a uniform magnetic field. Now this rod, it is rotating in anti-clockwise direction with the angular velocity omega, or you can say angular speed omega. Now what will happen, that the free electrons in the rod will move outward, and it will get distributed in this ring. So an induced EMF is set up between the length of this rod R. So the induced EMF is equal to BVDR, and when you integrate it from 0 to R, this is the induced EMF you are going to get. Now let us come to another concept. That is another concept. It is about resistance. This is very important. Here you see this is your A, this is your B, and this is your C, E, F, and all are this of same resistance. All are this of same resistance. All of these are of same resistance. Now if you have to find the equivalent resistance between A and B, remember that due to symmetry, the current in this here I1 and the current in here, this will be the same. this I1 and I, this is both are same. In AC, that means current in AC is equal to the current in CB, equal to the current in CB from symmetry, and the current in EC, current in EC will be equal to the current in FC. So here this joint we can separate it, we can lift it, that is we can separate this joint. If this is from symmetry, say all these are R, so in this case if you have to find the equivalent resistance between A and B, so in this case current in this AC is equal to current in CB, current in EC is equal to current in FB. So at in this case you can shift this C upward, that means you can disconnect it. That means you can disconnect it. That means you can disconnect it. That means your figure will be somewhat like this. You can disconnect it. You can disconnect it. Here you see, you can disconnect it. Here you can disconnect it. This is A, this is B. So now see, you can now easily calculate it, because here you see that these two are series, and with this it becomes parallel, and again these three becomes series, and this three becomes parallel to these two, and we can easily calculate the equivalent resistance between A and B. So these are the concepts which you must remember, and this will help you in both your competitive examination or in your board examination.